Okay, my name is Samuel Sakaras. I was always protected by my name from being called upon in class because teachers wouldn't be able to pronounce it. They were afraid to pronounce it. I'm going to be talking about dilemmas in benefit cost analysis, discounting dilemmas. It's important. This question is more than just academic because cost benefit analysis in many countries affects how public investments are undertaken or not undertaken. And it's kind of disturbing that after so many years we still have these dilemmas with us. I have many topics to cover, and so I would try to cover everything, but I will try to concentrate on the more important, which is the choice of discount rate dilemma. How does this arise? Basically, in benefit cost analysis, you have to relate future benefits to present day costs. This is done through discounting. You compute the net present value of investments. A key variable is the discount rate at which the funds are, the project flows are discounted. And one thing that's important to notice is that discounting both imputes capital cost and establishes the present value of future benefits. Now, the problem is what discount rate shall we use? Well, in fact, because of the distortion in capital markets, actually there isn't just a single rate, there are two. One is associated social opportunity cost rate, measures the opportunity cost of using funds. And the social time preference rate indicates how society values present day consumption versus future day consumption. The big dilemma is that discounting at the SOCR values capital correctly but undervalues benefits, whereas discounting at the STPR values benefits correctly but undervalues capital costs. And Baumholz in 1968 noticed that there is no single rate that can possibly accomplish the two things correctly. The current state of affairs is that in general people prefer to value benefits correctly and thereby are willing to undervalue capital costs, which leads to unfeasible projects being undertaken. It's an important question. Some people say this is a question of philosophy and not of economics. Cicilinsky said, discount rate embodies the tyranny of the present over the future. Some people remark how very large benefits in the future become very small in present value terms. And Weissman was adamant that this is the wrong thing to do. Now, I will propose a solution to this dilemma by essentially proposing that instead of using a single rate, we use both of them. We use the social opportunity cost rate to calculate capital costs and the preference rate to discount the benefits that may remain. And so the way this works is, as I give you an example, this is a classical project flow, investments in the beginning, benefits later. What happens when you invest? Well, when you invest, you need money from somewhere. So in fact, there is a funding flow. So money from somewhere is injected into the project. When the project begins to generate benefits, the first thing it has to do is repay the funding it received. And if it finished repaying it, effectively you will then have net benefits. Now the way you can see that is if you add these two curves together, because in this part they are the mirror images of one another, the net result here is zero. So essentially we have taken care of capital costs correctly measured by the social opportunity cost rate. And now we are left with net benefits that can be discounted at the social time preference rate, thereby effectively solving the problem. I'll introduce another curve into this picture here. This is the capital stock assigned to the project. When the funding is positive, the capital stock grows. When project benefits make it possible to repay the funding, the capital stock falls until it is fully repaid. Out of this, what I like to show is that the social opportunity cost rate is the feasibility hurdle rate. In other words, the project will be feasible provided it has an internal rate of return on values, the social opportunity cost rate. Why is this so? Let's imagine we truncate this project at this moment, and so what would be the internal rate of return of this left portion of the project flow? Well, that would be the same as the internal rate. Sorry, the direction. Yeah, that would be the same internal rate of return as of this segment, and the internal rate of this segment by construction is the social opportunity cost rate, because it is the interest rate with which the funding flow has been defined. Consequently, if a project actually manages to repay its capital cost, then it will have an internal rate of return equal to the SOCR. If in addition to that it has further benefits, the rate of return is necessarily higher. So this proves that this is the threshold rate. Now, there is a very easy way that I coined the phrase of two-ray discounting, actually using the two rays to compute the net present value. You can compute that quite directly from the net flow of the project simply by compounding forward these numbers at the social opportunity cost rate while the compounded value is negative, and compound it forward at the social time preference rate when it has become positive. And so that is shown here. If we compound forward this part of the cash flow, and we have a final future value which, when discounted at the social time preference rate, will give us the net present value computed with the two rates, which is the correct welfare measurement and no undervaluation of capital. Let me get the right button. Okay. Now, shadow price of capital is a concept that has been defined to overcome the problem that when you discount only with the social time preference rate, you undervalue capital. So they said, okay, we have the value capital, let's try to find what the shadow price of capital is. Marklin devised this in 1963, and the idea was he worked with an example, take a capital investment of K that lasts forever, has benefits of B forever, every year. What's the net present value? Well, it's the present value of the benefits minus the present value of the opportunity cost of capital. So the ratio of the two discount rates actually is the shadow price of capital. And so that allows us to rewrite this equation in this fashion: net present value is equal to present value of the benefits minus capital cost times the shadow price of capital. The project feasibility condition is that present value of benefits should exceed present value of costs, which simplifies to this that benefits in each year should be greater than the opportunity cost of capital. Again, SOCR is the hurdle rate. And notice, the social time preference rate is absolutely irrelevant to the question of feasibility of projects. Now, the estimates of STC in the literature are based on this notion of infinite capital allocation, which actually doesn't really make sense because projects don't last for infinity, they last for a finite period. However, the concept is correct, so you can apply that by taking the present value of the amortization of the capital funding received. You put that here and modify the flow by putting the present value of this amortization flow here. In the next two periods, which are investment periods, set it to zero and follow the rest, and the present value of this will be correct when discounted solely at the social time preference rate. Important take-home message from here is that the SPC is not generic. It is only valid for each project because you need to know for how long and for how and how much. Okay, a marginal cost of funds, I'll try to make this quick, is a proposed adjustment for the same understatement of capital cost. It is based on the notion that we compute how much does it cost to raise public funds and we multiply investments by that, but it doesn't work because capital is a stock, investments are a flow. So adjusting a flow to capture the benefit of a stock, the cost of a stock is a non-starter. Okay, the remedy equation is an interesting story. It is the the cornerstone of many estimates of the social discount rate. I can't really go very much into the details, but in essence, the problem is that the rate of discount is supposed to be a function of the growth of consumption. Most of you probably remember from basic economics how optimizing consumption between 2 years depends on taking the indifference curve and finding the tangency of the interest rate with this point. And it is true that wherever the tangency may be, this expression will be true. However, the equation is a tautology. Why? Because it holds everywhere, not just here, it holds everywhere. So consequently, the fact that it holds doesn't tell us anything, because actually the rate is not a function of the growth of consumption. On the contrary, the rate establishes the optimal point, that defines the consumption point, and therefore it's the reverse. So therefore this equation, even though it is widely used for this purpose, should not be used to define. Another such problem is the notion of discounting, declining discount rates. Many countries actually do this, using much lower discount rates for the future than for the present. In other words, not a constant discount rate. This was devised by Weizmann, who observed that, okay, let's say, what's the value of a dollar today, T years from now? But it's 1 plus the interest rate raised to the power of T. Conversely, what's the value of a dollar in year T today? Well, it's the inverse of the compound factor. So CF is compound factor and DF is discount factor. What Weizmann proposed is something that is actually quite seductive, and I must confess to you that I believed this for a long time. I bought this hook, line, and sinker. He said, okay, if this is true deterministically, then probabilistically, what we need to do is take expectations. And he said, this is what it should be. The consequence of doing this is that the discount rates decline through time, and the discount factors decline less rapidly than they otherwise would. However, I noticed this by quite chance. Let me tell you, this is a good story for the story of science. I forgot this expression. I said, I will derive it. And I tried to derive it from the definition of present value and found that the result is not the same. These two expressions are not the same. This is the way they are related to each other is here. And the fallacy that Weizmann fell a trap into, and me too for a long time, was to say that the expectation of the inverse of the compound factor is the same as the inverse of the expectation of the compound factor, which is not true. This is the correct measure, this is the wrong measure. This set of graphs explains the Weizmann-Collier puzzle, which this thing solves, but I can't go into that because I already have the 3-minute warning sign. So that basically the choice of discount rate now becomes quite easy. The discounting dilemma currently is that shall we use SOCR and understate benefits, or shall we use STPR and understate capital costs? We don't have to, because doing this method, you solve the problem without further ado. Now, of course, there is still a problem of what STPR variant you should use to discount those future benefits. And there are several. One is measures willingness to pay. You can use the SOCR. What did I do? Okay, yes. Yeah, you can use the SOCR to optimize public sector, and normative STPRs for any other purposes. Now, this is my concluding slide. I will not read it. It simply summarizes everything I said before. However, let me tell you what the significance of this is. Currently, everybody uses, or most everybody, maybe 1/3 of the countries uses SOCR, and maybe 2/3 of the countries surveyed use the social time preference rate. Those who use social time preference rates are understating capital costs and therefore risking undertaking projects which are not feasible. So actually, doing it correctly, all two-rate discounting does is essentially internalize the capital cost and make it another cost, just like labor or inputs or anything. And you can't ignore it. And once you internalize it, you solve the problem because all you are left with then is net benefits after capital cost that you can discount at any point because feasibility will already have been established. I really hope that this idea will catch on, and if it does, it might have good benefits. I'm very grateful for this opportunity